This webinar gives the overview of the strength test. When the force is applied to an object, the strength test is to evaluate the characteristic of the object based on the relationship between the magnitude of the force and the amount of deformation. The types of object for strength test include materials such as metal and resin, parts such as screws, and actual products. The purpose of a strength test is to determine the characteristics of object to confirm the strength, lifetime, safety, and durability of materials, parts, and products. The purpose and working characteristics of a strength test depend on each department. For example, the Quality Control Department conducts strength tests to ensure the quality of materials, parts, and products. For the test method, authorized testing methods such as ISO, ASTM, and company standards are applied. The work characteristics in this department is to perform routine tests with a large number of specimens. The R&D department conducts strength tests to investigate cost reduction of materials and parts and developing new materials. Unlike the Quality Control Department, this department sometimes develops its own test methods and performs a variety of tests rather than routine analysis. Strength testing is used in a wide variety of applications. This slide shows some examples. In metals and chemistry, the most typical fields where strength testing is used, various materials are tested in tension, compression, and bending. In the chemical field, strength testing is used to evaluate developed resin product. In the food industry, in recent years, there has been an increase in the number of cases where it is used to evaluate food texture, for example, the firmness of noodles and the elasticity of bread. In the pharmaceutical industry, it is used for extrusion testing of tablets and peel test of adhesive plasters, and in the life sciences, it is used to assess the strength of biological tissues. In the electrical, electronics, and automotive industries, strength tests are carried out on electrical wires and seat belts. There are various types of strength tests. This figure shows a list of strength tests. The light blue shapes in the figure represent the test specimens. The dark blue shapes represent jigs, which are the parts used for each test, and the dark blue shapes represent the test force applied to the specimen and the direction in which it is applied. The most typical strength tests are the tensile test, compression test, and bending test. In addition, we can also perform torsion tests to twist the test specimen, peel test, and friction coefficient test to measure the coefficient of friction of the test specimen by converting vertical force into horizontal force using a pulley as a jig. To perform these strength tests, it is necessary to change the jig according to the test to be applied. The following is a glossary of terms related to strength testing. This figure is called the stress-strain diagram. It shows an example of a stress-strain diagram obtained from a tensile test of a metallic material. The horizontal axis of this diagram shows strain, the ratio of material deformation, and the vertical axis shows stress, the test force per unit area material. The graph shows that when a metallic material is stretched, the relationship between strain and stress is initially linear, but yields at a certain point and eventually becomes a nonlinear arc-shaped curve. This slide first described the elastic and plastic regions, and the terms used at each point are explained on the following slide. The orange area in this diagram shows the elastic region, which returns to its original shape like a spring when the force is removed. The blue area shows the plastic area, which is the region that does not return to its original shape even if the force is removed. Using the spring as an analogy, the elastic region is the area where the spring retains its shape, while the plastic region is the area where the spring is stretched so hard that it stretched to its full length and does not return to its original shape. The elastic region provides data used in product design, which assumes that the shape will not deform, while the plastic region provides data for manufacturing. Strength testing provides test force in Newton and deformation in millimeter, from which stress and strain are calculated. Stress and strain are used to describe the property of a material, regardless of its shape. Stress is a physical quantity that indicates the magnitude of the force applied to an object, which is the test force per unit area and is given by dividing the test force by the cross-sectional area of the object. Stress is expressed in units such as Newton square millimeter or Pascal. Strain indicates how much the specimen was deformed before the strength test. The length of specimen before the strength test is referred to as the gauge length. Strain is given by dividing the amount of displacement from the strength test by the gauge length. The value calculated from this formula is usually expressed as a percentage. Next, we will discuss the elastic modulus. It is one of the most frequently measured indices of material properties. It is a ratio of resistance to deformation when a force is applied to an object and is actually expressed as the ratio of stress to strain. It is the slope of the stress-strain diagram in the elastic region, which is the region where the displacement also returns to its original state when the test force is removed. We discussed the tensile strength, which is obtained in the tensile test, one of the strength tests. Tensile strength generally refers to the stress corresponding to the maximum test force in the tensile test, which is the test force an object is subjected to before its break. The point at which the specimen breaks in a tensile test is called the breaking point, and the elongation of the specimen at the breaking point is called the breaking elongation. When an object is stretched, at a certain point the previously linear stress-strain diagram shows a different behavior. This occurs at the transition from the elastic deformation region to the plastic deformation region, where the displacement does not return even if the test force is removed, and this point is referred to as the yield point. When plastic deformation begins, there is the region where the stress decreases with respect to the displacement of the object. The point at which this phenomenon begins is called the upper yield point, and the minimum stress value after the upper yield point is called the lower yield point. This yielding phenomenon only occurs in steel materials and does not occur in non-ferrous metals such as aluminum and copper. For materials that does not yield, the proof stress point is used instead of the yield point. To determine the proof stress point, a straight line with the same slope as the elastic region line is drawn from any given strain point. The point where this line intersects the stress-strain diagram is the proof stress point. Particularly for metals that do not have a yield point, the 0.2% strain point is used, which is known as the 0.2% proof stress point. The yield point and proof stress are used as the important data to determine the design limits in the design of a product using metallic materials. This webinar covers the following topics. Strength testing is the study of the characteristics of an object based on the relationship between the amount of force applied to the object and the amount of deformation. The purpose of strength testing is to quantify the characteristics of an object through testing to confirm the material strength, lifetime, safety, and durability of material parts and product. There are several types of strength tests, such as tensile, compression, and bending test. The results of strength tests are represented by stress-strain diagrams, and the characteristics of objects may be read from these diagrams.
Excellence in science. Shimadzu.